board, so with Sigbovik's usual standard of punctuality, we'll get started. Welcome, everyone. Welcome to Sigbovik. I will walk all the way over to my laptop to advance this slide. I'm Jim McCann. I have been invited to MC tonight by the organizing committee. So first off, a big round of applause for the organizing committee. This is their kickback. The rest of the applause goes directly to me and the presenters. Welcome to Sigbovik 2K, where K is equal to 1. Juxtaposition means multiplication, and multiplication is interpreted as per Python. In other words, welcome to Sigbovik 2017. Friday, April 0th, the 31st of March, 2017 PhD DES, CDB, DBSA, PZB, O, SND. That's from a William Sigbovik, I believe. This applause here is preemptive applause for the speakers. So this Sigbovik, we're going to hear a lot of great research presented. We're going to have an introduction, which we're actually having right now that I think about it. We'll have talks, we'll have intermission, we'll have talks, and we'll have conclusions and future work. Now, different than in previous years, we're actually going to have the awards during the intermission. So while you're eating cake, you may also be getting an award, and that's pretty cool. Also different than previous years, we are going to have a time limit on talks. So talks will be allotted 5 minutes with 2 minutes for questions. Talks will be allowed to go slightly over, like you can go over your 5-minute slot by 1 minute, in which case you'll be taking time away from your question period. To enforce this, we have a timer set up over here. So the way it works is as your talk time ticks down from 5 minutes, it will play a gentle reminder tone once you start to go into overtime. Once you're into overtime, you'll have another minute. This is now cutting into your question time, so you should really try to finish up. But if you use all your overtime, it'll play another gentle reminder tone. Finally, your question time will begin to tick down. If you go over your question time, maybe through no fault of your own, another reminder will play. At which point, your talk is over. All talks get 5 minutes with the exception of keynotes. Keynotes get 10 minutes, but they must contend with a slightly different timer, and you'll see that shortly. All right, let's get into talks, and to begin, I want to welcome our first speaker, Jim McCann, famous Hollywood scriptwriter. Are you ready over there, Jim?
I'm ready, guys. Okay, are you ready to really get going on your script writing? With me, Jim McCann, famous Hollywood scriptwriter, PhD. I look out in the audience today, you know what I see? I see scientists, 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 scientists. I see a lot of scrubs. Sorry, build order problem. There we go. So you might ask yourself, what's the difference between myself, a drab academic, and a glamorous movie star? Well, let me tell you, better writing. I'm here to help. Here's my resume, not a picture off the internet. I'm Dr. Jim McCann. I'm a famous Hollywood scriptwriter, PhD. I've visited Hollywood. I once watched a show on television and many other qualifications. I am also the recipient of the first ever Sigbovik Totally Real Scriptwriting Award 2017. Terms and conditions apply. Sigbovik's only solid gold award. Don't stand there. I'm here today to tell you that you're doing it wrong in all of your talks. Your writing is terrible. But with my help, you'll be doing it right. That's a joke. Tip one. Don't break the fourth wall. How often have you had people come up to you after a talk and say things like, make eye contact with the audience. Stop staring at the ground. Why won't you look at me? Seriously, why won't you acknowledge me? I asked you a direct question. Oh gosh, now I'm starting to wonder if I even exist. I'm never coming to one of your talks again. Well, this is horsepower. Don't pay attention. Your content lives in its own little world. It's surrounded by four walls. We call those walls 1, 2, 3, 4. And when you make eye contact with the audience, which admittedly I'm doing now, and I'm trying to put this in kind of your format, but I'm telling you it's wrong. Okay, but when you make eye contact with the audience, what you're doing is you're breaking, yeah, that's the audience there. They're behind the fourth wall. That's why it's the important one. You're breaking the fourth wall. And when you do that, you break the audience's immersion. They can no longer live in this beautiful little world that you've constructed. No, don't do it. No. Tip 2. The omniscient narrator is a crutch. How often has it been, you've gone to talk and you've seen slides like, since the base relation is reflexive, the pullback through F must be as well. Or, we have shown that if the algorithm terminates, it produces the correct result. What remains to be demonstrated is that it terminates on all inputs. These are boring and there's just too much information. Nobody knows that much. That's unrealistic. Instead, convey the information through the interaction of several characters, no less. Show, don't tell. For instance, you could do something like this. Word on the street as the program terminates. Really, Mac? You're going to come at me with that? You're a detective, not a fisherman, right? Maybe I just need to bait the hook. A bride is exchanged. Gee, thanks for the contribution, but I suppose I could part with the proof. But I don't know what it means. I don't know either, but I aim to find out. I think I maybe messed up the accents there, so sorry about that, folks. Multiple people, see how much more realistic that is. Now, you may say to me, Jim, famous Hollywood scriptwriter, PhD, I got a question. My question is, if I do this, my talk's going to be super long. And then what I tell you is, look, you're trying to write a whole season. You're not just writing the pilot here. You can use less content. It's fine. Tip 3, III. You know what this is? This is the world you're creating. This world does not stop at the audience's whim. Wake up, sheeple. Your world may have a coherent arc, it may have a coherent story, and you may be tempted to walk people through that story from the beginning to the middle to the end. That's boring. What you want to do is you want to have people come right in the middle. Everything needs to be happening right away, okay? And then maybe an establishing shot of a castle and some birds, you know, to kind of like lower the action. And then, boom, right into a fight scene. But before we get to the climax, a flashback, which ties it all together. Whoa! Tip 4. You know what this is? I don't even have to ask. This is an outline slide. Get rid of it. Throw it in the trash, though. Don't litter. Instead, do things like make twist ending slides. Like, then we found a college. Or, turns out you wrote this story. Or just cliffhanger slides. Like, come see our talk next year. Or proof. These are great ways to build suspense in your talk and keep the audience coming back season after season. Tip 5, the most important tip. 3-dimensional characters. We see this all the time in academic talks. You've got a character that's got a single static value, it's unchanging, it's typecast, it's only going to act according to type. But we know that good plots have characters with an arc, who change, who grow, who learn, who defy their type. You know what that makes the stuff up here? ungood. But if you want to make it non-ungood, you can use some writing skills. So, for instance, instead of writing something boring and two-dimensional like this, let x equal 3, y equal 1, require x less than y. Therefore, the proof fails. Don't do that. Okay, that's not the right pitch. We'll keep it higher from now on. Instead, well, first, comparison. Why use comparison when you can use romance? And secondly, why have your variables stay the same values when they can change as characters? That's type is brilliant. Now that's a story. Of course, if you don't want to actually use writing skills, we have software aids too. So for instance, if you want your characters to be on a path, you can use text on path. You can give them an arc naturally. Or if you want to make three-dimensional characters out of any two-dimensional characters, there's always word arc. Especially these three-dimensionalizing presets here. Well, those are my 5 tips, and I hope that you're now doing it right. And that's a joke. The fictional character Bob Fossil for this accent, which I stole. He's on Mighty Boosh. You should watch the show, it's pretty good. And roll the credits. Thank you, Jim McCann, famous Hollywood scriptwriter. Now, if you're willing to take a few questions, we can have the next presenter come down and set up. All right, any questions for the presenter? I will try to do that accent really, really hard. We'll see what happens.
We were promised by the previous Jim McCann that there would be a timer. Where is it?
Oh, shit! See, the trouble is that Jim McCann, timer controller PhD, was busy. Yeah. I swear there'll be a timer for the next talk, though.
Does dynamic typing help with character development?
Oh, absolutely! You want dynamic characters. They're the best. All right, if there are no further questions, I think we can move on to the next presenter. Let's see, do you find that microphone?
Testing.
So I have to turn this mic off and you have to turn that mic on. This microphone is now off. I'm noticeably less feedbacky.
Okay, testing. Can you hear me?
You need to move it out.
Some people attach it to their beard.
Move it up. Okay, is it moved up?
No.
You hear me anyway?
Did you flip the switch?
What, the switch? The switch. I was not promised a switch.
There's an on-off switch on the top, which should make the display light up.
Oh, off doesn't work, does it? Testing. There we go.
Yeah.
Okay. So here, I would like to show you a new exciting result in poster design. I'm going to show you how you can optimally design your posters for academic and other purposes. First, I want to show you a bad poster. Here's a bad poster. I can complain about this poster because I made it myself. Here's a bad poster. Don't make your posters like this one. Next, I would like to show you a good poster with bad sound. Here's a good poster. You should make your posters as much as possible like this one. So, I would like you to think about this as an optimization problem. We computer scientists have known for decades how to optimize software systems for maximum performance and reduce costs to minimize unnecessary expense. So here we have Amdahl's law. And Amdahl's law tells us that when we optimize our software, we should be sure to focus on only the parts of the software that are going to execute for long periods of time. We shouldn't waste our time optimizing things that don't spend any time anyway. So how does this work in the context of a poster? There's a solution, so I appreciate some solution because it's terrible.
I would suggest that you simply turn off the microphone
we need to optimize for the common case in poster usage. So, what is the common case? Let's look at the life cycle of posters. A typical poster might take about 4 hours to create. A typical poster might be displayed at a conference for an hour and a half or so. But what happens to the poster? What happens to the poster after it has been displayed? Well, a typical acid-free piece of paper can last up to 1,000 years. 1,000 years. That's almost 9 million hours. And what happens? The poster gets rolled up and put into a poster tube, just like this one. Let's look at this in a graphical way. Now let's consider the costs of producing this poster. As we all know, ink for printers is expensive. How expensive? More expensive than blood. So, we have a new result in graphical theory. That is the zero-color theorem. An optimal poster uses 0 colors. It minimizes printing cost, it minimizes creation cost, and it minimizes shipping cost. Because when you get to your destination, you just buy a new piece of paper. That's your poster. This is not a problem. You can still stand there and repeatedly explain why your work is not irrelevant. Now, some of you may feel overly constrained by this design advice. This is a new result, only to be seen in Sigbovik, not in the paper. But you might be assuming, after hearing this result, that you're restricted to a poster that is boring and looks like this: white paper on a white wall, secured with thumbtacks. But no, paper comes in a wide variety of colors. Your poster could be black. Your poster could be red. Your poster could even be blue or green. Some of you may be wondering if this is going to be too limiting. How will you convey your important message that you're trying to convey with your research results with your poster? How will you convey these important ideas using this simple design idea? Well, let me show you some examples. Suppose you have proven a safety theorem regarding some type system. How will you present that in your poster? Well, as everybody knows, the international color of safety is neon yellow. Now, suppose you're presenting results pertaining to a database. You've developed an interesting database system. Well, you are not limited to only a 2-dimensional arrangement of your poster. As we all know, databases look exactly like this. Suppose your software has a layered architecture. That too, you can handle no problem. Now, suppose you have a machine learning algorithm that you want to describe. Machine learning, how is that different? Well, in machine learning, the algorithm actually changes over time as it gets new information, new input. So how will we reflect that in our poster? Well, that's no problem either. So, I want to show a prototype of future work in this direction. The future work looks like this. I have it right here in the poster tube. Sponsors are still needed for this results. If you're interested, talk to me afterwards. So in conclusion, blank posters are the best posters, and drink tickets are awesome. Any questions?
I would ask that the next speaker come down to start setting up while we're answering some questions.
Phil Wasler, University of Edinburgh, famous PL researcher. Thank you for your beautiful talk. I'm curious though, why should I care about this? In particular, how does this compare to the posters that I made in 1983?
Using this technique, you can create seamless posters. In 1983, you would have printed your posters on a dot matrix printer, on fan feed paper. And then you have this problem where the paper always comes apart at the perforations. This way you can get a piece of paper that is exactly the right size for your poster. Yes?
So with the modern prevalence of archive, it is easier than ever to publish a paper that no one will read. Do you see a future in like an online platform for publishing posters that no one will see?
No, because they don't come with drink tickets.
Yeah, so this first one, are you going to be making an art gallery tour? Because this reminds me of a modern art piece called Black on Black. Secondly, as we mentioned, no one's seeing it. Have you considered the accessibility implications of this technology? Because it seems easier to make this accessible to the handicapped than the traditional poster.
That is a fantastic idea. This is a great extension of this work. Yes?
What about blank PowerPoints too?
Oh, nobody should be using PowerPoint.
How can you properly call it a zero-color theorem when I believe you did have one color to present the main idea?
Oh, it's all about the ink used in printing the poster. Whereas if you buy your paper pre-colored, you don't have to use any ink.
But how do they color the paper?
Are you set to go?
All right.
Our next presenter will be talking about increased robot mobility through empathic interactions. Take it away.
All right, so our motivation for this work comes from a robot famous in the news about a little over a year and a half ago, Hitchbot, which was a passive robot that managed to cross several countries without actually any actuator or movement, just by asking people to pick it up and carry it around. It only survived a couple of days before being decapitated and thrown out of streets. And so it's interesting to note why it failed. And I have two theories for this. One, it ended up in failure. The second is it didn't elicit enough empathy from people who it interacted with. So to increase robot mobility, I theorize that we can inspire empathy in people. That'll help them move the robot around, help the robot get places, and thereby increase mobility in places where the robot would otherwise have trouble going. So here's our robot test platform. Cute little guy. It's very good outside, moving over rubble and debris, but it's kind of small. It's only about this high. So it has some trouble in human scale environments like stairs and elevators. And so the possible solution is to have people help out with these tasks in human environments. So our first experiment here is how long it takes for a person to help the robot enter an elevator. Here we have two conditions. The first is sitting next to the door and looking up, sadly, unable to reach the buttons far above its head. And the other condition is kind of bumping into the elevator repeatedly, hoping it will open eventually. And we measure how long it takes for a random passerby who's not getting in the elevator to come press the button out of an entrance. Our results are that the bumping condition has a much lower time for someone to come press the button, at which point the robot can go in the elevator and go up a couple stairs. So these clearly statistically significant results inspire us to move forward and have an algorithm by which the robot will learn how to better inspire empathy. So in this case, we want to maximize, use some reinforcement learning, have the robot maximize helplessness. Here we define helplessness as effort over effectiveness. We want the robot to climb these stairs as fast as possible. Now, the robot can climb the stairs, they're not that much higher than it, but it would take a very long time. And so it's much faster to wait for a person to come over and help. And so we inspire empathy by having the robot vary its gait parameters as bumping into the stairs. And over time, it learns to become more and more helpless. This is sad. I'm going to help you. is able to maximize mobility in human brain. So, learned helplessness inspires mobility, and we can now use these results in other domains. So, the first of these is manufacturing. You might have a robot that does some operation assembling parts, but if the robot is really bad, you might have a person come over and help. So this could do a number of things. It can invigorate manufacturing in the United States and bring back more good jobs. Working class Americans to help robots in manufacturing applications. And the other domain is in driverless cars. If the car learns how to drive poorly, like going very slowly under 30 miles an hour and stopping for too long at red lights and not taking the Pittsburgh left, a person might come in and help it out by taking over at the wheel, thereby increasing the robot's mobility. And so, this is my theory for learned helplessness in increasing human-robot interactions. Thanks.
Any questions for the speaker? And could we have the next presenter come down and begin to set up?
So many advancements in like robotics often cite search and rescue applications as something that could be like useful. Do you think that this new technology could be useful in search and rescue applications as well?
Certainly, there are very, very well-trained emergency rescue workers who could help the robot out in these difficult terrains. You know, if it's a fire, the robot may not be fireproof. You got a guy in a flame retardant suit, picks up the robot, puts it over the fire. Problem solved. Yeah. Question?
Have you done any research on the fact of different appearances of the robot to elicit empathy? For example, giving it really big eyes.
I have not, although I do know that there's some real research with robots have big screens and they play with how big the eyes are, and it actually does have an effect on the perceived friendliness of the robot. In my case, I just put googly eyes in the front of it.
Have you done any research on putting the robot in the film?
I have not. I think that's a little too advanced for the stage. Although if someone has money to fund a study in Philly, I'd be willing to try it out. It's not that far away.
Have you considered putting two robots together and see how they compete to be the most helpless?
I'm not. That would be a fascinating experiment. Yeah, and I assume it would make people more likely to help the two robots if you had twice as much helplessness.
Do you think this could be used not just in the case of robot mobility, but in other computer tasks like getting algorithms to work faster by looking like they're trying harder than they are?
Definitely. It would be an interesting challenge to see how you get an algorithm to look helpless. It doesn't have eyes or googly eyes or legs or antenna, and so it could scream. So it would be interesting to see perhaps having the computer make a dog's whimpering noise when it's having trouble with computational load. Future work. Certainly. Corner?
Could this strategy potentially have negative effects on robot mobility? For example, if the robot was trying to go down a floor in the elevator?
I would assume it would have to make a downwards flailing motion. Thank you.
Set up and ready to go?
Yeah.
All right, our next speaker will be talking about BlackBerry debugging and is one of two folks who contributed unequally to this work.
Yeah, and I'd like to know that I'm the one who really didn't contribute to this work. So bear with me here, I'm going to try. So I'm going to be talking about using BlackBerries to help with our debugging. Huh? Is there a button? There's a button. Did that help? Can you hear me better now? I turned it to on. Usually on is supposed to help. Good? Okay. All right. So the reason why I'm thinking about using BlackBerry for debugging is that mosquito control is a really, really important issue facing us. Now, mosquitoes really aren't useful for anything at all. This is a known fact in the entomology world. But they carry all of these really horrible diseases, like, for example, West Nile virus and dengue, and these really bad things that we don't want to get. So it's important to try to get rid of our mosquitoes. And one approach that's been found recently to be very successful at eliminating mosquitoes is using various leaves of different types of plants. And it turns out that if mosquitoes like to lay their eggs in standing water, and it turns out that depending on the type of plant that you put in that standing water, the mosquitoes can become more or less likely to actually lay their eggs there. And then furthermore, the type of plant that you have in the standing water can also affect how likely the mosquitoes are to emerge and survive into adulthood. So we've tested this to try to understand the effects of different types of leaves by setting out buckets of water with different types of leaves in people's backyards. This was actually the only part of this study that I had anything to do with. I helped dump the buckets of water. And what we found, this is really interesting, what we found is that if you look here on the y-axis, this is the average number of egg rafts per day that the mosquitoes lay. And you can see that it's very, very high for blackberry. Mosquitoes really like laying their eggs in buckets of water that have blackberry leaves in them. But if we look at the average proportion of the larvae that actually survive to adulthood, that's very, very low with the blackberry. Sorry, is there a question?
Yeah, how is this related to computer science?
Computer science? I'm sorry. Is this not the special interest group on biological opportunities for vector insect killing? Well, I guess I'm in the wrong place. So I guess then what I really want you to take away from this, the important thing that you should know about blackberry with respect to mosquitoes is it's a trap. Blackberry leaves attract mosquitoes and make them want to lay their eggs, but then they kill the mosquitoes, so it's a naturally occurring ecological trap. And this is real research, by the way. And as for these blackberries, I can't help you with the debugging. Maybe get a fly swatter. That's all I've got for you.
Have you considered larger fruit like oranges or lemons or apples?
Well, let's see. Actually, I think we might have we have elderberry and serviceberry. I guess those are pretty small too. But I don't know. Maybe that's some good future work. Yeah.
Have you tried other types of berries, like maybe raspberries, or maybe if you put them into some effort into them and throw them into pies?
Ooh, pie. I wonder if mosquitoes like pies. I like pie. If you want to kill me, you can lure me with a pie. That might work.
Have you seen the effectiveness of keeping some sort of snakes near the buckets of water? Specifically, I don't know, python maybe?
Pythons. That's an interesting thought. So the pythons might, I don't know. See, this is interesting because the mosquitoes might try to take a blood meal from the pythons, but the pythons might try to suffocate the mosquitoes or something. It's a promising line of research.
I'm worried about the applicability in this new and dynamic world. Have you studied putting more modern types of phones like iPhones to see how this affects the mosquitoes?
Yes, well, mosquitoes, I think, usually have a little bit of trouble with the swipey thing. So they tend to prefer this more old-fashioned thing where you've got the little keys. That seems to work better. They can work in groups to kind of jump on them. And I think that's one of the main reasons why BlackBerry is so effective here.
I'm also interested in Apple products and other genres of fruit. And how the results.
This is a promising line of work, and I think it's one of the really important ways that that entomology and computer science really intersect. And I think there are a lot of good directions for exploring this intersection between these two fields that really don't have anything to do with each other.
Have you seen the effect of varying the different kinds of water that you use? Like, for example, using sea water instead?
Seawater? Well,
what about a sea filled with ants? Like an antsy sea?
An antsy You guys are good.
replicate the study, do I have to worry about voiding my warranty?
On your BlackBerry?
Yeah. Well, on the bushes, right?
Yeah, I mean, gosh, do you really still have a BlackBerry to test this? Alright.
That was really excellent. I'm hoping that the organizing committee next year remembers that acronym and puts that on the webpage. So. All right. Well, we're moving along well. I should probably stop this timer before it goes off. And maybe, if we're lucky, our laptop connections will continue working. Awesome. All right. Are we ready to go?
Maybe. You guys hear me?
Yeah.
Awesome.
I'll cover for a little bit of mic setup so you can do that. All right. So our next talk is presented by someone without a name and is called Effective So thank you very much for joining us, Nameless One.
Thank you. I'm very glad to be here. So I've noticed that everyone seems to have a bit of a split in their side. I'm going to ask that you put that away for a little bit because we have a very important topic to discuss here, and that is effective multi-threading in Bafunge. First, a little bit about me. I'm Zach. So Bafunge 93, for those of you who don't know, is a very special programming language. It is a two-dimensional programming language, which for all of you normal programmers out there, I'm sure comes as a shock. But really, it's a wonder of programming design, because you have a program that very, very well maps out exactly what it does. For instance, here we clearly have a FizzBuzz program. I mean, I think that's obvious the way the control flow works. And you see, it's very intuitive. In addition, it has the wonderful ability that it can actually modify itself as it runs. So it can choose to change its operations on the fly and perform a completely different function as it loops around. But the thing is, Bafunge is not the most popular language. In fact, it's not even in the top 5. And after tons of research and lots of speculation, we think we know why. And that is the lack of multi-parallelism, concurrency, and threading. And really, as we know, in an age of big data, it's really, really hard to do anything if you can't just throw lots of chords at it. Here are some actual quotes, mostly from Twitter, about the need for parallelism and concurrency in Bafunge. I would like to present to you my remedy to this, and that is the language Bafungeal. And for those of you wondering, yes, this is a real program, and yes, it took me far too long to make. Bafungeal is a language extension for Bafunge 93 that supports full parallelism and concurrency. It has constructs that allow for fork join parallelism, as well as concurrent modification to a global grid space. In addition, it has built-in locks to prevent races within the code itself, and allows for a lot of really complicated programming to emerge from such a simple and elegant language. So the two main language constructs we introduce are the fork operator, =. =, when it's encountered, will cause the current program to split the cursor into 2 new cursors, one on either side of the =. From there, execution continues normally, with each thread having its own copy of the stack, and continuing until it reaches point of termination. From there, it will pop off the top value of the stack, and push it on to the stack of the original controlling thread. Once both the threads have ended, the original thread will continue its execution with the values that it obtained from its children. We also have the critical operators, the braces. Now, the braces act sort of like a block in, any other language. They surround a region that can only be accessed by one thread at a time, and they prevent races in your code. It's a very, very elegant, very simple way of doing concurrency in Bufundle. So here's an example of a fork join application in Bufundle. This is computing the Fibonacci sequence by spawning one thread for every value in the fib event. Now you might be thinking, oh, so the impressive thing is this has only O of n span. You might be thinking, isn't this O of fib n work? But no, it's in fact O of fib of n plus 1 work. We also have concurrency in Bufundle. For instance, using the normal locking mechanisms, we can have race-free printing of hiding. But we can also introduce our own spin lock that performs the same function without needing our built-in constructs. And so, as you can see, they're really just there to make things more convenient. Now, I know we're running out of time, but it's very important that this is a fully fledged programming language. And so here we have proofs of the type safety. Now, I'll give you just a few more seconds to read through it. Yeah, everyone got that, right? Okay, so here, before my time is up, we have a live demo of this program here. And as we can see, this is RNG as a service with HTTP over Bufundle. Using multi-threading to its fullest capacity to both print out the output and print out the random number at the same time. I think that's timer's wrong. My timer says I still have 5 minutes left. Wrapping this up, I'd like to thank all these people for various and sundry reasons that I don't have time to go over. Look it up later if you want. Also, you can find, this is all actually real, it all runs, it's all, I spent way too long on it. You can find all the code there. Start on GitHub, please. Any questions?
How does this compare to other dense, abstract, nonsense languages like category theory or JavaScript?
Clearly, the elegance of this language makes it far superior to anything else that exists. And it's just so fast. Up there.
I have been made aware recently that Swift can take emojis as operators. Have you considered actually increase your operator spread namespace?
There's actually a separate project going on called Emoji Script, in which all operations are emojis, and you can actually construct functions out of how the emojis look. That's a topic for a different presentation, though.
So, have you considered three-dimensional programming languages? And what would you suggest for the symbol for the fork in a three-dimensional case you could have?
Yes, I think for that we'd be best suited by an X that's flipped on its side, and we'll spawn 4 threads, so it's even more efficient. Thank you, everyone.
That was really amazing work. Thank you for sharing it with us. Let's see. As the next presenter steps up, I think I'm going to do a quick demographic survey. I did this last year. We'll do it a bit faster this year. So I'm always interested in how many Sigboviks people have attended. So anyone who's attended one Sigbovik, please raise your hand. If you're not raising your hand, you're not paying attention. Okay. 8 Sigboviks? Okay,
Yeah.
this one's a good one. 12 Sigboviks. 11 Sigboviks. All right, we're keeping the flame. I'm glad no one claimed to have attended 12 Sigboviks. How's the setup going?
I'm just trying to get the video to work here.
Procedural question.
Yeah. Is the official pluralization Sigboviks or Sigbovik?
More of a question for to make that decision.
Ooh, we've been neglecting our duty.
Let's see. Did we not get the video? Or are you on?
You got it.
Awesome. Great.
Is the audio working?
Yeah, this is audio. This is audio.
Okay. All right. So, Saul, do you have an official word on whether it is SIGs or Sigbovik? Yeah, okay.
Yeah.
So if you're on the Sigbovik organizing committee, could you raise your hand? Now, if you vote for Sigbovik, please lower it. Count how many people have lowered. This is I don't think that's quite how that's supposed to work.
Yeah, sorry, I can't speak at the audio word. Oh, there you go. Never mind. We're good. We're good. All right.
This is what plays every time I walk across the room.
So I'm doing a video presentation, as you might be able to see.
I'm still going to start a timer just to make sure you're
Yeah, do it.
All right, cool.
Whoa.
Hello, my name is Tom, and in this presentation I will present my breakthrough research on solving computational problems using PowerPoint. I will explore to what extent PowerPoint can replace conventional programming languages, as well as the benefits and limitations of using PowerPoint for such purposes. But first, a quick disclaimer. This presentation is not sponsored or endorsed by any real or hypothetical corporation located in Maryland, Washington. The views and opinions expressed for those of the author and do not necessarily reflect those of any such corporation should one exist. Only trained PowerPoint professionals should attempt to reproduce the results of this research, and the author will not be held responsible for any material, physical, or emotional damages caused by such attempts. So with that out of the way, we can proceed to the background. So as you know, PowerPoint has hyperlinks and animations, which can be used to add interactivity to your presentations. So we have links here, and we also have animations, which are particularly interesting because you can trigger them in different orders. So you can use these to make interesting things, like applications, games, typical things that you make in a slideshow editor. But until recently, it has been unproven as to whether you can do all things using PowerPoint, whether you can solve every computational problem with a dedicated PowerPoint file. And this is largely because in order to prove such a claim, you would need to create a Turing machine that runs in PowerPoint, or you'd have to be able to show that every Turing machine can be run within PowerPoint. So without further ado, the Palindrome recognizing Turing machine. So here we have a Turing machine that decides the language parameters of even length. So you can see that, like a normal Turing machine, we can move this tape. This is implemented completely with animations. There are no macros or anything else. So I can write to the tape, of course. We'll give it a simple input like this. And of course, I can also execute the Turing machine. So here we have the Turing machine's current state. And in order to continue execution, unfortunately this doesn't happen automatically, it needs a little bit of encouragement. The user has to click on each orange region. So I can click randomly essentially, and PowerPoint will just advance its computation. So that was the input 1-1, so this should end up being accepted. And we can see that it does indeed end on an accepting state. And I can rerun that with another input, and it would reject accordingly depending on what it is. So this is nice, but what we'd really like to be able to do is run any Turing machine in PowerPoint. Fortunately, this is easy because the PowerPoint Turing machine is programmed entirely using punch cards. So for example, this card says that whenever the Turing machine is in state 0 and it reads a 1, then it should write a blank, move to the right, and then move to state 2. But if we change where these holes are located, we can make the Turing machine do something else, and essentially just take any transition function of any other Turing machine. All of this is accomplished using over 1,600 alternative programming languages, offering cross-platform support on both mobile devices and potentially relevant desktop operating systems. In addition, this drag-and-drop programming means there's no text and no syntax errors. But most importantly, you can use themes, word art, and transitions like PowerPoint's infamous for in your code. It requires asymptotically fewer auto shapes than when implemented in alternative slideshow editors, definitively proving PowerPoint to be exponentially more capable than competing software. But perhaps most notably, the PowerPoint Turing machine shows that the PowerPoint iOS app is in violation of Apple's App Store guidelines to emulate alternative apps and execute arbitrary code. In the future, I'd like to research making PowerPoint code more scalable and optimized, so that one day, every application you run on your computer can be run within PowerPoint.
So do we have any questions? Oh, yes.
Why?
So I do actually have like a history using PowerPoint for these types of things. I kind of joke that the first programming language I learned was PowerPoint because the computer, which like when I was like just playing around with the computer, this was one of the few applications that I actually had installed. So like whenever I tried to make something interactive, I actually like learned how to do those types of things by adding hyperlinks and stuff. Yes?
I'm sorry.
The first text-based language that I learned was BASIC. This is not a joke. This is actually the first text-based language. Yes.
Have you considered working with Ryan O'Science O'Donnell, who is known for his many PowerPoint?
No, I haven't considered that, but that sounds interesting. I have noted the quality of his presentations, though, which is quite impressive. Yes?
Can you integrate with the work presented last year in Deep Excel?
No, so I did hear about Deep Excel, and it did inspire me to work on this. But I think that, so like Excel is a program which you think it's pretty reasonable that you'd be able to do these types of things in Excel. PowerPoint, it's a little bit less expected that you'd be able to do computational things in PowerPoint. But I think the next direction really is going to Word, right? Like trying to, and there's some work in making DFAs in Word, and with some success. But thank you.
I realize we're not even halfway through yet, but I gotta say that this has been a stellar year for Sigbovik so far. I have been really impressed with the things I've seen. Woo! And I have no doubt that our next presenter will live up to that standard. No pressure.
What are your thoughts on the fact that all the presenters have broken the fourth wall?
I'd have to refer to that to my alter ego, Jim McCann, famous Hollywood scriptwriter, and I'm not sure my throat can actually take doing that accent.
Excuse me. It's Jim McCann, PhD. He worked hard for those extra letters.
Right.
Has there been a Sigbovik presentation on
Just a public service announcement for presenters. When you're switching the source, if you poke the screen, it's really unintuitive. I'll just have to walk over and do it for you, because I can't even describe the button you have to press. Yeah, good. We're setting new bars here.
Poke the screen.
Just poke the
Got
screen.
it.
It's like using an iPad, but with a specific region you have to be in.
Huh.
Checking for signal. Are you plugging into or plugging into you're actually on Max. Oh. Okay. Other PSA. Aux VGA is blue, regular VGA is black. Don't get confused.
Okay, thank you.
All right, so this is a presentation which is dry and boring, and it's about garbage collection. Take it away.
Yeah, so I have to apologize here. Despite having, as I did before with the hand raising, been to 5 Sigboviks now and having presented at a few of those, I totally forgot that these talks were supposed to be funny. I thought we were just supposed to give a lecture on some topic in CS that's important to us. And so I thought I'd talk about garbage collection, which is one of my research areas. So it's a 5-minute talk, just bear with me, it'll be over soon. So garbage collection. So many programming languages require the programmer to explicitly allocate free memory using malloc and free. But then in 1960, John McCarthy with Lisp introduced garbage collection, which does the allocation and freeing of memory automatically. So, let's see, how does this work? So there are many types of garbage collectors. I'm going to be able to go through only a few of these in the time that I have today. So broadly we have tracing and reference counting. There are a number of sub-types of garbage collectors under tracing. I'm going to go through a few of those. I probably won't have a chance to talk about reference counting today. So tracing garbage collectors. The basic idea with tracing garbage collectors is that you start with pointers that you have on the stack or in registers, and you call these the roots of, oh, wait. This is really embarrassing. Sorry, I gotta take this. Hi, Mom, this is really a bad time. Can I call you back later? I'm giving a talk. Yeah, no, there are a lot of people. Look, I've got 3 minutes left. I can call you back in 3. All right. Sorry. Okay, it's really going to take a minute. Okay, fine. All right. So you trace pointers through this, and the reachable objects are live. You should keep. Sorry, no, I wasn't talking to you. I'm just going to keep flipping through the slides. You can read them, right? No, I don't need my old review books from high school. Why would I need those? Yeah, I put them in the basement because I didn't need them anymore. No, I don't need that either. All right, yeah, okay, I guess I can keep those. It's gotta be an easier way to do this. Look, can I just tell you what I want to keep? Move out of my room and like the rest of the stuff and just clean up. All right. No, okay. I don't want you to do all my cleaning for me. Okay, what? All right, I can take care of it myself. I don't know, probably sometime over the summer. I don't really know. I've got the POPL deadline in July. Maybe sometime after. Okay. Well, why can't it just stay in the basement? You're redoing the basement. What's wrong in the basement? Never mind. Okay, fine. I'll just tell you what to move to the garage. I don't know what you should do with the stuff that's still in the basement. Just get rid of it. Yeah, or can I just take care of it? Or yeah, whatever. Just throw it out. I'm just really in the middle of something. Next week. come to Pittsburgh for it. Okay, I'll call you back later. Yeah, school is fine. No, I'm not graduating this year. I haven't even proposed yet. Okay. All right, bye. All right. I'm really sorry about that. All right, how much time do I have left? Oh, crap. Okay, I'll just stop here. Any questions? Yes,
What was wrong with the basement?
It was this whole long story. I don't know. Yeah.
Have you considered, this might help your mom, have you considered writing a number on the top of every piece, every item that you own? That just annotates like, you know, how many times you're going to need it in the future.
As future work, and also like some of my stuff is kind of cyclical. For that. Yeah. Yes.
What would you think of implementing a borrow checker on your things so that you know beforehand when things are going out of scope and they can be moved to the garage, so to say?
Well, I think if something is borrowed, then they can just deal with it. Like if I've forgotten that I loaned something to somebody, then I don't really care. Yeah. Yes.
Have you considered just buying the next house when your basement's full?
Well, I still need to worry about what protocol to use to move things. That's tricky in itself. Yeah. Any other questions? Yes. Inside there.
Did anyone come to collect your stuff?
Still don't know. You know, the runtime is kind of lagging. Yeah, hopefully it'll happen soon. Yeah, you again.
I'm just curious, the stuff that's in your basement, I don't know if it's just your stuff or perhaps some of your ancestors, like older generations, have left things. I was just worried, you know, maybe your mom doesn't want to throw out something that's actually hers or perhaps her mother's or.
So I hear there's some work in hierarchical methods of doing this, where I can just like kick that up the chain and say like if it's my mom's stuff, that's her problem. I'm not going to deal with it.
All right. So while we're switching over again, I wanted to tell a really, really amazing joke that I read on the internet. Just really good, but the trouble is I've forgotten it. So actually, I had a thought that maybe we could try this year, and that's that, you know, I tend to run out of material around halftime. So maybe while you're watching the awards presentation and getting cake, you could also jot down some jokes for me, just on scrap paper you have, and maybe just leave them up by the timer. And I'd give them a shot, you know, if they look reasonable to me. Yeah. Oh, I remembered it. Okay. This is the quality of joke I'd like, by the way. What do you call a bear with no teeth?
Gummy bear.
So if you have something of that quality or potentially better, can you jot that down for me during intermission? That would be awesome. Oh, excellent. So it seems that we have a presentation on fake news logic coming up next. So let's all welcome the speaker.
So this talk will be a little bit different. Rather than doing some research in CS, I thought I'd look at an application of logic to a very significant real-world problem we're dealing with right now. There's been a lot of misinformation with regard to the present administration's declarations of what's true and what's not. And so, you know, being from CMU, I thought the best way to tackle this is to formalize it.
So what I've come up with is a logic for describing fake news and other relevant facts. So first I'll just quickly review what kind of logic I'm using. So I'm using standard epistemic logic, where we take some set of propositions phi, it's countable, and then we take some set of agents that we want to describe. Here there's only going to be one agent we're going to refer to, and his name will be the D. The language of epistemic logic is generated as follows. All propositions are members of the language. Then we use negation and, so Boolean constructions. And then also statements of case of D phi, which is D knows that phi is true. So a model in epistemic logic is typically a tuple consisting of a set of possible worlds and an indistinguishability relation, or sorry, an access relation and V. So this relation just means, so if W tilde W prime with the subscript D there, that means that from the world W, the D has access to or thinks possible world W prime. Okay. And then evaluation is just assigns propositions to sets of worlds. So for instance, it might say that P is true at both W and W prime or such. So the difficulty with coming up with logic for this is standard semantics for the K operator don't work. So standard semantics for the K operator operate as follows. K sub D phi is true at a world if for all accessible worlds from W, phi is true at those worlds. However, clearly we've seen declarations that don't quite align with this because certain declarations have been made where it's not true at any worlds, right? So the way we're going to adapt this is with D semantics. K sub D phi is true at a world if there's some world that exists out there that I consider possible, or the D considers possible, where that's true. So the D thinks of a world that's possible, and there's something true there, then he knows that that's a fact. Luckily, this allows us to articulate contradictions in this logic. With standard semantics, we can't have two contradictory statements true at the same world, but now we can. And for a list of contradictions to support this, go to that link. So I'll quickly describe this access relation. So it certainly needs to be irreflexive, because it's not always true that the D has access to his own world. He seems to be. But furthermore, I'd like to posit that it's actually acyclic, which means that no matter how far the D traverses along paths of accessibility, he never arrives back at this world. So in no possible world does the D know about this possible world. So the novel part of this logic is going to be two new operators I'm going to add. Fake news and alternative facts. And we're going to restrict the application of FN to just propositions. Namely, I don't want fake news to be applicable to statements of knowledge about the D, because nobody can tell the D what he knows or doesn't know. So first of all, the first feature we want to have is that if the D doesn't know that P is true, then P is obviously fake news. That's just the end. But the second more important thing that we want to capture here is whether or not the D likes particular propositions. So what we're going to do is we're going to expand our set of propositions as follows. So for every P that occurs in phi, we're going to introduce a proposition L sub P. And we should read that as the D likes P. He likes that proposition. Okay. So then the sufficient condition. So the sufficient condition that we're going to state now is that if at a world the D does not like P, but knows P is true, then P is fake news. And as a result of this, if you combine these two sufficient conditions, we arrive at this fact being a tautology. Namely, P is fake news if and only if the D does not like P. So alternative facts is a well-known phenomenon. It first came to light when one of the meeker, less articulate henchmen, known affectionately as Melissa, declared some things to be true that were kind of contested. And another one came to stick up for him and said, you're saying it's a falsehood, and we gave alternative facts to that. So I read into this a particular metaphysical claim of the following sort. Truth is only a linguistic artifact. There's no real world that exists out there to which truth can ascribe meaning, and it's relative to any linguistic schema that I might come up with. As a result, our alternative facts are just those statements which can be regarded as true under some linguistic framework. So if there's a way to construe a fact as being true, it's an alternative fact. So the semantics for this are going to be then that AF of phi is true in a world just when there is some model in some world that makes phi true. So in this world, I can say that phi is true if I can construe some model in the world at which phi will be true. And notice that this captures the semantic freedom that we want to capture from the administration. So this is the kind of speaking that we see regularly exercised by the administration. And What's nice about this is that alternative facts don't rely in any way on local circumstances. So we call this expanded language logic of fake news, so FN. And to demonstrate its expressive power, we model a well-known phenomenon, the Bowling Green massacre. And to kind of motivate the significance of this, the real lesson from Bowling Green is who will cover, who will care. So this is what Bowling Green looks like in our logic. Don't think too hard about it. And lastly, I'll just conclude with some comments on axiomatization. So FN, the modal operator FN, is easily axiomatized, but AF is not. That's because it refers to meta-theoretic facts. And this is in line with our thinking of what we're trying to capture here, because any axiomatized system would undermine the very flexibility of truth that's essential to its administration. Thank you.
So currently your system only includes one agent, the D, but have you considered adding other agents, specifically Russian agents?
That's a very good question. So there hasn't been any proof yet there's any interaction between D and Russian agents. Yeah.
John Sterling, famous PL researcher. I'm curious if you considered using the internal logic for the topos of sheaves on the alt site.
On the what?
The alt site.
On the alt side, okay. I hadn't considered this yet because I don't think it's logic can internalize topoi, but certainly if the D can do it.
That was really excellent. I'm glad you managed to fit it into 7 minutes also. So I'm getting really excited because we're only one talk away from the alternate keynote timer. Admittedly, maybe that's not the best thing to be excited about. All right, are you set up over here? Okay, so if you haven't checked it out in the proceedings yet, this next talk is on WYSIScript, which is probably one of the most colorful papers in this year's proceedings. And given that it's such a colorful paper, I hope that this is also a colorful talk, although maybe I should ask you beforehand, do we need to do any projector calibration so that we can interpret the programs correctly?
This is probably close enough.
Okay. Well, without further ado, WYSIScript.
Well, hi everybody. I'm Will, and we're here to tell you about WYSIScript. So we got to thinking, what makes a programming language different than just plain text? And we stared at this screen for a while and really thought about it. And then I think we came to some conclusions and we figured out really what makes the difference between programming languages and plain text is that programming languages have all these colors and nice formatting. And we wanted to we tried to understand why did we invent this process where we write all this complicated text to get it to format the right way when we could just be programming by controlling the formatting itself. It didn't make sense, so we did some work.
So our proposal is to simplify and streamline the process by removing that unnecessary first step. So our new paradigm, the programmer just applies the colors and formatting directly, and then that produces the desired program behavior. Let me see if I can attach this thing. The answer is maybe. All right. So previous work, we will note that programming languages have not always been text-based. For example, the first widely used programming language, built a new machine for each task. Did not employ text at all. Neither did its popular successor plug wires into it. However, unfortunately, by the mid-1960s, the text-based paradigm had become fully entrenched, and we want to break outside of that box. So we're going to look at this demo. I don't know, does this work? Wow, look at how it works. Okay, so this is available online. You can go play with it. Let's enter full screen again. Okay, so here's our WASD script editor. Let's just write a simple program here to, I don't know, how about we multiply two numbers and then add a third number. We'll write a function for that, and then we'll apply it. So we do need some text to act as sort of a substrate for the formatting. So we'll just see this. Okay, so let's see here. We want, the first thing that we want, is this big enough? Maybe I'll, good. Okay, all right. So the first one, so we want to, we have a tree structure, so we're going to want to add things together. So now, obviously, like built-in things are in bold. The color of this, if we want to add two things, so the color is ADD. All right. Now we're going to have two arguments to this. The first argument, so it's going to have to be smaller because it's an argument, of course. This is also going to be a built-in. We're going to multiply two things, and you do multiplication with a dot, so that's D07. And then that's going to take two arguments. Those need to be smaller still. All right, now these are going to be function arguments. For a function, we employ the popular Roy G. Biv calling convention, which is also employed by the Randy Kosh Bridge. So we're going to bold them as function arguments, and the first function argument, of course, is called red, so that's red. The second one is called orange, so this is orange. All right, and then, so where are we at now? I think this needs to be one size smaller. This is going to be our second argument to add, so we're going to bold that. And this is going to be our third argument to our function, which is yellow, I think. Okay, and then all of this stuff now is going to be our function definition. So we're going to give that function a name. So that's the background color. So what's a nice, let's call it khaki. I don't know. All right, so that's khaki. Of course, to mark it as a function definition, we need to italicize it like that. All right, now, we're going to need a couple more A's in here. So let's, this takes three arguments, so those are going to have to be small. We're going to want to call khaki here, so then we're going to have to put khaki, there we have that. All right, so now we're going to want, let's just do some numerical constants here. Those are underlined because they're immutable. The first one, let's make, so I should talk about how numerical constants work, but I only have 13 seconds. So let's make this one 5, and this one is 6, and this one is 7. And somebody can do some math to figure out what this should be. And then we'll just, we'll save this to another variable called, I don't know. What's the name of it? Tomato. That's a good name. This needs to be bigger, and we're gonna. Oh, that's smaller. Okay, we're gonna print this out. So this is printing as facade, and we're gonna print. This shouldn't be underlined. This is not gonna work. Okay, and then we want to print tomato. All right, and then we'll run this thing. Syntax error. So let's fix that error. There we go. Okay, now we'll run this. And we can run it. Let's show an example here. So here's an example. The nice thing about this is here's an example program for the Euclidean algorithm. The nice thing about this is that since the text doesn't matter, you can make it say whatever you want. We can run this, for example, and we can get the GCD of 45 and 105, and that's what Now, because the text can be anything, of course, it would be really nice if maybe there was some automatic way to sort of adjust the text. So we have, this is, WYSIWYG, to our knowledge, is the first program that supports syntax texting. So we're going to go to the actions menu, and we will just syntax text this program. And this slightly increases the readability just by adjusting the text to fit what the format is doing. We think that in time, text may come to be seen as a very helpful way to understand instruction. Here it is, and we have no seconds. So come talk to us if you have questions. Thank you.
I think I'm going to preemptively walk over here just so I can try to poke the right. What connector are you using? Factor 7. Okay, same connector. All right. So this is the last talk of the first half of Sigbovik. This is also our only keynote this year. And we've invited Tom to give a keynote because we were pretty sure he couldn't describe his work in only 5 minutes.
Yeah, I'm a mess. I'm just going to hold this up like I told you. I was awarded a keynote slot, and all you need to do in order to get a keynote slot is get your paper in Sigbovik cited by Eric Demain, MIT researcher. So just do that, and you're gonna say, "Oh my God, it's from fire." I'm probably not gonna need the whole 10 minutes. This work is real, as is the way, and I'm actually really excited to see so many real pieces of research in this conference this year. And it's just way too hard to explain the whole thing, so I'm just gonna give you a flavor, and there's a long video you can watch, and you can read the paper. So here's a fun fact for you. All files contain bytes. And I know what you're thinking. What about the empty file? The empty file is not a file. Fact. Extensions. File extensions mean nothing, whether it says txt, sml, exe. Nothing. Fact. Some bytes are best. Some bytes are worst. In my opinion, here are some of the bytes. These bytes up here, these are the ones that appear on your keyboard. Those are the best bytes. They're so easily accessible and they're pretty. Everyone can agree that the number 40, hex 40, is the @ sign, right? These other ones, are they emoji? Are they tabs? Are they beep sounds? Those are useless bytes. They're bad. We don't care for them. Moving on. So the project this year, ABC, is a C compiler that produces completely printable executables. What that means is, you give it a C program, it gives you an EXE or TXT, and it will contain only the things that appear on your keyboard. That is, bytes that start at hexadecimal 20 and end at 7E, and nothing else. You'll notice like 0 is missing. That's a pretty useful one. So why is this so hard? Well, first of all, you've got to write a C compiler. That's hard. Turns out C is like kind of gross and complicated. But you can just do it. It takes about 13,000 lines of SML. Then you got to make an executable file, so it has to be valid. And it turns out I looked at a bunch of file formats. EXE is like the only one that's remotely plausible. Most of them have to have some magic number that involves non-printable bytes. But you can just barely make EXEs work. It results in a program that is actually quite long. You also have a vastly reduced instruction set because, here is, where is it? Here's the book, right? These are all the instructions that your x86 can do. But you only get, this many of the instructions in the program, which sucks. And also, the data in your program has to be printable, because that would be cheating if not. And some really important instructions are missing. And so move, which is like the instruction. You don't have interrupts, so you can't communicate with the operating system, which some people like to do. You also don't have backwards jumps, you can only jump forward, which is a little puzzle for Turing completeness. All the remaining instructions are only available because the arguments need to be printable in weird addressing modes, and that's really annoying. And standard techniques for assembling don't work because the size of even a load of an immediate depends on what immediate is being loaded. So as you lay out the program, it changes the size of the program, so that's annoying. And x86 is terrible, even if you're just doing this normally. The code has to fit in 64 kilobytes due to the trick that I use to create backwards jumps, which involves overflowing the instruction pointer. Which means that you need to make the code pretty small, but you actually have to write a pretty good compiler that optimizes the code so that you can do anything within that 64 kilobyte segment. And self-modifying code is cheating, because then you would be executing instructions that were printable even though you didn't put them in your executable. Makes the problem too easy, so I don't make any self-modifying code. And due to unreasonable Sigbovik policies, the paper can only be 20 pages, right? So, and by the way, the paper in Sigbovik is an executable program that you can just directly execute. So you can find that on about page 129 of the proceedings. That would explain why it contains pages and pages of gibberish. It just have to be there in order to make a valid executable. Yeah, it is a problem with Sigbovik. This is why the paper's title is ZM tilde space hash. It's a miracle that you could make it kind of readable. This is basically the thing, and it involves, well, forcing the instruction pointer to start in certain places so that you can put a word in there, and that's why the R is capital, et cetera, et cetera. It's also why the paper is 20 pages long. So solving this, the way to consume this is to read the paper. It's got some puzzles in it, and it's just too much to make bite size. I'm sorry about that. But you can think about a puzzle, which is how do you compute the bitwise OR operator with just these instructions? Because these are the only instructions available. And as a hint, I've made the ones red that you would actually use. Then I'm going to walk through one of the things, then I'm going to run the program for you since it has some behavior. Here's another puzzle that's kind of fun. It's a fun solution. So if you want to do anything with your program, you have to call DOS, probably. These are like DOS executables, not like modern ones. You need to use this interrupt instruction, and you can't call that because the opcode is CD, which is not printable. So, what do you do? Well, there are other ways that interrupts can happen, and one of them is like the timer interrupt is just going off all the time. You can also just ask for an interrupt through that instruction that we don't have. And so at program startup, I have some handwritten printable assembly that will copy the handler for int21 on top of the illegal instruction handler, which is the thing that would normally produce sig-ill if you're in Unix. I looked it up, there's no Sigbovik. This seems like something that we could research. And so then you just need to execute an illegal instruction to exit the program. And it turns out we just happen to have one illegal instruction in that set. Like, why the heck is that instruction there? Just RPL field of segment selector? I don't know, maybe it was placed there by our forebearers in order to make it possible to write completely printable executables. So you can execute that instruction. What's great about it is that this is what that looks like, just some weird ass instruction. The encoding of that instruction is awesome, right? So somewhere on page 9 of the paper, you can see the text that just says like LX4 space see ya, and that is actually the illegal instruction that triggers, and then it jumps into the DOS21 handler and exits. Now you can only use that trick once, unfortunately, to call DOS. It kind of sucks, but it leaves the interrupt flag cleared, and so you can't ever do it again, which is fine because like you only exit once. And we do want there to be some way of like doing something in the program other than just looping and exiting. So, oh yeah, there's some other puzzles too. Like even just loading a value into the register is hard. It's kind of fun. So I want to show you a demo, and basically what it comes down to is, although you cannot use the operating system, you can communicate directly with some peripherals that happen to be on your motherboard. And there were some peripherals that predate like plug and play, that predate configuration. Those peripherals are just sitting there listening on a certain I/O port. For example, the AdLib sound card. So if you don't care about timing, or you have a dead reckoning on the timing, then you, oh no, I need to plug this in. Okay, hold on. Is it this? No, this. Well, hope this works. Is that good? Well, let's try it. Okay, here we are finally in computer world. I'm using a DOS emulator called DOSBox, but this also works perfectly fine in real DOS, as long as you have the right peripherals. I wanted to show you that the paper is all printable bytes, but unfortunately it's too big to even load it through the editor. What it does is it takes on the command line the description of music in a format called ABC. I didn't invent this format. So if I say ABC, It'll play those notes and then exit. It accepts more complicated input, including the possibility of playing more than one track at the same time. Now I'll just leave you with the built-in tune that plays if you don't provide it with any music of your own devising. Perfect music. Here we are. Okay, Sigbovik, never gonna give you up. Are there any questions? Looks like we have 1 minute. But if you ask questions, you're simply forestalling a cake, so everyone should know. Yeah, you got it. All right, no questions. Let's have cake.
All right, so while you're all rustling around, rustle around a little quietly, because we'll be setting up for awards while we're setting up for cake. If you're a presenter in the second half and you haven't checked in, check in. There's only 1 or 2 of you. Those of you who are thinking about distracting yourself before this is the largest procedure seems to me that at least some people are eating cake. And since at least some people are eating cake, it's time to begin the Sigbovik Awards. Now, the Sigbovik Awards have been prepared by the committee carefully, agonizingly, over at least, I think, 15 or 20 minutes they took thinking about these awards. But before we start on the announcement of the Sigbovik Awards, one, please continue getting cake while the awards are announced. If you received an award and are in line for cake, it's up to you to decide whether you want to give up your place in line to receive the award, ask the person next to you in line to save your place, or try to cut back at the beginning of the line with your award. Another important announcement is that those of you who pre-ordered proceedings, please go pick them up if you haven't already. Saul is trying to figure out how many he can actually sell. And he might sell your pre-ordered copy if you don't pick it up during this intermission. Also, change is being given in rolls and pennies. The proceedings this year is noticeably the thickest proceedings we've ever had, which is something pretty amazing. By about 20 pages. By about 20 pages. Okay. Let's begin the Sigbovik Awards ceremony and people talking while they eat cake presentation. To do so, I will also need the awards, and I'm not sure where they are. But I'll just sort of start and hope the awards find their way to me.
Jim, I got awards for you.
Okay, here come the awards. Here they are now. All right, we begin. With apparently an award that I find. We begin with the award for most frighteningly like real research. This award celebrates papers that are frighteningly close to actual research. This award goes to RRR for UUU. They're Christian Gardner and Ziv Scully, a queuing analysis of urinal use. This is a wonderful paper. I had a chance to look at it. Are either of the authors present? All right. Well done. Thank you. Our next award is a new award this year. It's called Most Executable. And that award goes to ZM tilde tilde octathorpe Pretty octathorpe C with ABC by Tom Murphy 7, Dr. Tom Murphy 7, PhD. And this capitalized Printy, I guess the award is probably not executable. All right. Let's see, is Dr. Tom Murphy in the house? Oh well. We'll set that aside. The next award is the award for excellence in coincidentally, blindly writing, creating titles, and submitting similarly relatedly with related titles. Which doesn't make a lot of sense until you consider that this award is given to the degenerative adversarial networks paper and the generative unadversarial networks paper. And this award has actually been specially designed so that we can present it as follows by taking the award, creasing it, and then tearing it down the center. And giving one half to each set of authors if either are in the house. Please come down.
These guys are not here. We'll mail it.
Okay, we will mail these halves, which actually is nice because they're closer to envelope size. Okay, the next award is for making next year's proceedings shorter by closing off an area of research. And that is for, that goes to David Renshaw for efficient computation of an optimal portmanteau.
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 French.
Okay.
sorry that I missed this.
Let's see. The next award, I better just read it here, is titled Having a Future Works section that highlights its own vagueness by using progressively increasing font size and color visibility, an excellent abstract, though one which has been used as a joke in prior years and also for studying an important unsolved. Anyway, good, yes. Automatic distributed execution of LLVM code using SQL JIT compilation. Is this one with authors present?
They're from Portugal.
All right. Will we know this one as well? Wow. Okay, the most likely to get our program chair reported award goes to Fake News Logic. And that was also an excellent presentation. Are you still in the house? Well.
You got deported.
Would anyone like to take this to him?
Guantanamo?
Really? Deported? All right. And I think that leaves us only with the Best Paper Award, which goes to Emma Stone for La La Land. I might have the wrong envelope. Ah, yes, it's a raffle. The Best Paper Award goes to, so I got two, I'm going to put one back. Unfolding it now. Is this the shortest Sigbovik paper? All right. I'm going to hand that to the organizing committee. Let's get it filled out officially. Right over here.
Oh yeah, great.
Excellent, excellent. And I believe, yeah, it'll get filled in. And that's it for awards. Wait a second.
There's a People's Choice at the end.
Yes, we'll have a People's Choice Award at the end, but we have another great half of Sigbovik to watch first. All right, so coming into the second half, if you haven't yet gotten cake, it looks like there's still a little left. I haven't actually gotten any food yet, so I will be eating the remainder of the cake, which is not taken.
Thank you very much. One quick thing. If you put in a pre-order, please check your email and respond. I'm just trying to verify that my accounting of who has gotten their pre-orders field is correct.
All right, and if anyone has jotted down joke suggestions for me, are they down next to that laptop? I see some pieces of paper. I'm hopeful. There are two of them, so there'll be two jokes in the remainder of Sigbovik.
Can we just submit a picture of our face?
Oh.
Interesting. It's probably too subtle for me to understand as a joke. All right, let's see. I received a joke book. It claims to be the funniest joke book ever, with over 500 jokes. Clap up my friends. I guess I'll find out who my friends are tonight. Excellent. And we have one schedule rearrangement. And that's gratitude. Again, no name. But all right, then I will therefore relinquish the microphone and start the timer. So this is Call for Partners, Romance with Rigor.
Alright, so this talk's something a little bit special. This is something from the Sigbovik industry track. As all important startup ideas, we're a little light on the implementation. We've got a very lean development team between 0 and 1 people at the moment. But we're big on ideas, and we're really hoping we can get the venture capitalists in the crowd excited. Okay, so our name is call4.partners. We own that domain name, and our goal is romance with rigor. Okay, so there's a big problem that's probably facing most people in this room, which is that academics are a sorry, lonely bunch of people. It's a Carnegie Mellon audience, so I don't need to spend too much time on this, but just to make you feel a little worse about yourself, I'll go with it. Okay, there's really no reason for me to tell you this. you're probably all crying yourself to sleep at night. You've all lived through this. I don't need to reiterate what I will. Okay, and really, the thing that has driven academic audiences away from the standard dating site experience is that you never know what you're going to get. So sometimes you go on, you get your first match, you go on one date, and you have an excellent experience. Someone cute like Ryan Gosling treats you with a lot of respect, very good looking, even though it's a little bit of hassle, it's great. Alright, but then you go on your next date, and someone is just way out of line, is texting you every moment, wants you to cite all of their work, and it's not the right way to treat a person, and you just get sick of it, and you stop using the thing, and you go back to your paper. So there's a solution, right? We're academics, we know what works, and the way to consistently deliver quality results is through the process of peer review. And so Call4.Partners is the first and only dating site to generalize the peer review model to the world of online dating. Okay? And we've all been in love, we all make a few bad decisions in the heat of passion, and this is why we need a council of disinterested third parties. Right? So anyone who's ever received a paper review knows that these councils never make inaccurate decisions, and so what we do is, much like sort of your friends list on hip chat services such as AIM, you've got a sort of partner committee to make these important matching decisions for you. And so we got a couple of example reviews based on anonymous faculty from the department. These guys are savage. Reviewer D, who may have also been involved in the fake news logic paper, really thought some of the figures were dissatisfactory for some of the submitters. Reviewer 2 thought the submitter was far too short. And I think Ed Clark must have reviewed one of these because reviewer 3 was very excited about model checking. And so as you can see from the sort of the blatant honesty of these reviews, this is a level of technical accuracy very seldom seen in the world of online dating. Alright, and so of course, it wouldn't be a good technical presentation with a bit of evaluation, so we're currently running a user study, which I'm sure all of you wish to participate in. It involves multiple page views, at least one hot single in your area. There's no matches yet, but it's beta. We're still in a round C of funding. We've only got about a $10 million valuation so far. But because of this small sample size, we've achieved an infinity% success rate with our matches so far. So we think this is a very promising technique. In conclusion, author number 1 doesn't want to be alone forever, so please do partake in our user study. We might even add features at some point. We all encourage you to check out Call4.Partners. All right, thank you. That's the end of the presentation. Looks like we got a lot of time for questions. Yes?
Does your work use Hall's marriage theorem?
So we're sort of we got more of an emphasis on software engineering. We're actually looking for some good theoreticians. So we like to put the Shapley in Gail Shapley, if you know what I mean. So we're encouraged to apply for an internship. We're very interested to have some of those skills on the team. Yes?
Is your website currently properly accessible so you can do blind reviews?
So not only are our reviews double blind, but we actually have double blind dates as well. So in a traditional blind date, you don't know the person you're dating, but in a double blind date, you don't even know why you're dating. Anyone else?
All right, with that, let's thank the speaker. So I've received some amazing jokes. So during the setup, I'll read a few. So for whatever reason, folks seem to be really obsessed with things without eyes. So what do you call a deer with no eyes? No idea. What do you call a fish with no eyes?
Why fish?
Yes! These are great. What do you call a deer with no eyes and no legs? Still no idea. And now one I don't have a question or have an answer for, but I'm interested in. What do you call a fish with no eyes and no legs? Okay. All right, looks like we're ready for Who Sorts the Sorters. Take it away, please.
Hi everyone, thanks for coming today. First, I'm legally obligated to start out with a slight disclaimer. This talk is rated PG-13 for mild violence, occasional sexual algorithmic content, and disturbing images and use of algorithms. So if anyone watching at home or in the room is under 13, please avert your gaze or pretend you're 14. So sorting. Sorting is pretty much one of the first topics people learn in an introductory programming class, and there's good reason. You know, we have a straightforward proof of an optimal lower bound, we have a straightforward implementation of it. All the intuitive algorithms we come up with are demonstrably worse than these lower bounds, and it's a deceptively simple task. And what I mean by this is, say I give you this list, which is 318572, and I'll say sort it. And most people in this room can probably tell me, hopefully, that the sorted version is 123578. And how'd you do that? Well, the 1 goes there, and the 2 goes there, and so on and so forth. But as anyone who's ever taken an introductory programming class knows, that's not how programmers work. Everything needs to be an algorithm. You can't just put a list in order, there must be an underlying algorithm. This is a very important point. So, most introductory classes will explain this and then move on to describe some algorithms. If you don't recognize some of these, I'll go over them in a bit, so don't worry. This is the average runtime of these algorithms, sorting the 3 random shuffles of a list 10 to the 5th long. Okay, well, that's good, but which one's the best? Well, if we put them in order, we see that quick sort's the best, followed by merge sort, so on and so forth. Okay, so we need to sort these. I guess I'll use quick sort, but why? Why is quick sort the best? In fact, how do I know what the best sorting algorithm is for sorting algorithms? Okay, well, first let's take a brief aside and talk about sorting algorithms. I'm going to go really quickly through these, so if you don't understand them, just pretend like you do. Merge sort, take a list, cut it in halves, sort both sides, combine them. Quick sort, take a random element, sort things smaller and larger than it, and then put them back in order. Selection sort, pick the smallest element you haven't used yet, put it next in the list. Insertion sort, pick the next element and put it in the correct place in a sorted sublist. Odd even sort, this is probably one you guys haven't heard of if you haven't heard of them. You take odd even pair inversions in terms of the indices, fix those, and then you fix even odd. Basically it's bubble sort, but instead of going through every index, you go 1, 3, 5, 7, 9, 0, 2, 4, 6, 8. It can apparently be parallelized. Who cares? It's basically bubble sort. And comb sort, which is basically bubble sort, but instead of doing every, you start with distance n over k, n over k squared, etc. So you get smaller and smaller. Again, it's bubble sort, who cares? So what happens when we do this? Or rather, how do we even sort an algorithm? How does that make sense? Well, really, if you think about it, the only thing you need is a less than operator, right? That's how sorting works. You say, if this is less than this, you do this. So what is less than for an operator, for an algorithm? Well, we'll say an algorithm A is less than algorithm B if, when sorting 3 random lists, it takes less time. Now, someone might say, why do you run it every time? Why not just run it once and sort the output? And there's a very good reason for that, and the reason is shut up. So we do that. We take these algorithms and we sort 3 random shuffles of all these algorithms, where running each one is sorting 3 random shuffles of the lists 1 to 10 to the 5th. And we see some interesting results. Merge sort takes about, I don't know, what is that, 6 minutes or 5 minutes, give or take. Some of the slower ones take closer to 800 seconds. I'm not going to try and convert that on the fly. Okay, so we put these in order. We said merge sort is the fastest. Interestingly, insertion sort is fast now. It beats quick sort, which is surprising since quick sort is supposed to be quick, hence the name. And comb sort, which was originally one of our fastest sorts, is now slowest. Cool, so that's interesting, but wait a second. I just put these in order. Okay, so what if we take a sorting algorithm that determines how to sort the best sorting algorithm for sorting algorithms? So these numbers are all determined by the average runtime sorting 3 random shuffles of all the sorting algorithms, sorting 3 random shuffles of all the sorting algorithms, sorting 3 random shuffles of lists 10 to 5th long. And now you see we're starting to get to some impressive numbers. Like quick sort takes about 19 minutes. Now, I don't know about you, but I don't like waiting 19 minutes for my sorts. I like waiting 4 hours, like I do for comb sort. Okay, and we see the same ordering here where merge sort is the fastest, takes about 17 minutes. Again, insertion sort is surprisingly quick. all the way down to comb sort, which is surprisingly slow. But hold on a second. I only have 40 seconds left, so no. So what do we see from this? Like I said, insertion sort is surprisingly fast, and comb sort is surprisingly slow. I have a good theoretical idea for why this is possible, but all the experimentation stuff is wrong, so I don't know. In fact, it's actually kind of interesting because this is sorting on non-constant time operations, which has never been done before. I tried to find papers for like 5 minutes and found nothing. So this is actually an interesting topic if anyone wants to look into it. So future work, obviously we have to look at third, fourth, and so on, order sorting algorithms. Something about quantum computer sorting data. Again, this is actual possible research. And now there's other meta-analyses we can look into. For example, if I want to do a search algorithm, how do I find the best search algorithm to use? If I have different databases, can I have a database to manage them? How about a container for containing containers, aka Docker? Or if I have multiple cache invalidator algorithms, I want it to be fast, so how do I manage the cache invalidator for those? So yes, this is kind of opened a whole branch of research for meta-analysis of algorithms, and that's all I have. So thank you. Any questions?
John Sterling, PhD student. I'm curious how this compares to dependently sorted algebraic theories.
So am I. Why don't you write a paper and tell me about it?
I have a question, son. Is this why I'm paying for college?
Yeah? Yeah?
Do you have any algorithms for sorting people who are trying to sort algorithms that are trying to sort algorithms?
Just wait for next year. Yeah.
Just sort all of your sorting algorithms? It seems like you only need to sort once, so finding the minimum sorting.
Shut up. I needed something to present on, okay? Yeah.
I noticed your slides were in some sort of order.
So yes, if they were actually in PowerPoint. So if there any way to do some sorting in PowerPoint, you know, I'd be interested in looking into this. Yeah?
I'm still waiting on the violent violence.
That was cut due to time constraints, unfortunately. Yeah?
When considering filtering data, how do your algorithms work on sorting lists?
There's no such thing as sorting. Sorting is a conspiracy. Some might even call it fake news. Yeah.
Have you tried the sorting hat?
And with that, thank you.
So this is pretty exciting because it is a tech demo.
Yeah.
And so I understand you wanted to call for a few volunteers.
Yeah, give me just a second. I'm going to give a brief introduction. I made some slides during the
I
other
see.
talks. So,
Okay, well I will start a timer.
I will read the proceedings later, so sorry if I missed your presentation. But anyway, so my name is Keith Mackey. I like playing with LEDs. So today I'd like to present a modular approach to state-of-the-art big data visualization. And so for those of you who know a little bit about big data, well, data can be kind of big, but it seems like over the years our data has actually gotten smaller and smaller. And so people talk about how important it is to work with big data and to understand how to use big data effectively, but you can't even see it when it's on this 2.5-inch hard drive. You know, it's inside your laptop, and so you need to use some sort of technology to try to visualize the data. And so often you're using some kind of monitor, which is a fixed size, and so you can't necessarily get it as big as you might want it to be. There's other technologies like projectors and things, but really there's some fundamental desiderata that we want to have when visualizing big data. And so first, it has to be able to visualize big data. It has to be portable in the sense that any practical researcher can take it with them, you know, when they have to give a talk, say, or go to a lab and do some work. It should be scalable in the sense that you can visualize digits galore, really, more digits than you could ever really want to. And then it has to be really nerdy because that's awesome. So so the design that I came up with was just to take some strip lights and wire them onto a panel in an alphanumeric compatible layout. So I chose the Union Jack layout, which is a 16-segment design. And so each panel has 107 RGB LEDs with built-in shift registers, and then I'm using a couple of Beagle buttons to wire them up and go. So yeah, just quickly before we get to the demo, the paper does show some interesting results in that we compared this with some other basic classic big data visualization technologies and found that ours was clearly superior. And so yeah, let's get to the demo. So I need like half a dozen at least volunteers. So people in the front row or two can just come here, and we'll quickly get this up there. So okay, yeah. Unfortunately, so you should maybe if you can come around and get it.
Let's all run up.
Sorry, noise is off. Okay, very good. So yeah, we just want to file this in a little bit here.
Where's the camera?
No, it's okay. All right, very good. So I've got 8 panels that I put together and brought in today, so we can play around with this. So all right, very good. Let's get some data up here. So yeah, how about
we're not on the camera right now. We need to get that.
Sorry, so if you give me just a second here. Unfortunately, my screen, the wire has come loose on it, and so in order to see what's going on with the system, I actually have to like hold this in place. So here we are. Okay, I have switched windows here. Okay. Okay, there we go. So, and it looks like this has disconnected over here. Give me just a second. Turn this guy back on. Sorry. Okay. All right. No, it looks like those are not going to work for us too. No, the battery is definitely on. So okay. Just a second to check this. Oh, this one is also off. Sorry. So yeah, bear with me here. This is we had it in the hall, and it had been working at the time. So actually, maybe we'll just go ahead and use this other set of panels here. So okay. All right. So let's go ahead and visualize some data here. So somebody want to like call out some data that they want to visualize? Alphanumeric is fine. 3, 5, 12. Okay, yeah. So we can just put some data up here. 35, 12. Yeah. So and this is pretty big too. You notice. So the other thing that's really cool is since we're using these RGB panels, we can actually visualize in several colors. So the data, like I said, can definitely visualize in alphanumeric as well as some punctuation too. So we can type out things like Sigbovik, and that's pretty cool too. So all right. Yeah, I guess. I don't know. If you guys just want to like shuffle off at this. Yeah, that's yeah, all right, perfect, great. Any problems will be repaired later. So okay, great. Questions? All right, yeah.
The data was big. I don't think it was big enough.
No, absolutely not. And so, yeah, I'm really excited to start exploring. And if you read through the paper, I've got some interesting ideas for future work. We have thought about if we could get some grant money, like doing drone swarms to actually like fly data in the air. That they could get really big if you have a lot of drones with LEDs. But even with fixed configurable panels, you could do like a dot matrix layout that was scalable and get even larger, high resolution images of data. That's really big. So yeah. Yeah, so I have flown with these, and actually the TSA agents really get irritated when you try to explain yourself. So, like, no, I'm not saying that they were accusing me. I was like, okay, so I want to explain my project in this bag. It's this, like, data thing that I've been working on. And the TSA guy's like, dude, just throw it on the scanner. Like, we don't care. And so, yeah, and, you know, you can talk to multiple agents, and eventually they just get irritated, and it takes you off. So, okay. Maybe, yeah, I guess that's all the time we have for today, so thanks, and I guess,
That was really cool to see hardware projects in Sigbovik. I feel like we haven't seen hardware projects in a little while. Maybe this will inspire follow-on projects next year. I think that would be great. Honestly, if someone just makes even larger data visualization, I'd be fine with it, you know. I feel like creative folks out there will come up with something
Alright, beat my
more
baseline.
exciting. Yeah. And of course, cite is paper if you do. So I realized that I actually do remember more than one joke. And one of my favorite jokes of all time is the reverse knock-knock joke. So I hear some oh no's in the crowd. So do you know how the reverse knock-knock joke works?
Knock knock.
Who's there?
Interrupting cow.
Interrupting cow who? It worked. The reverse knock-knock joke worked. Awesome. All right, I'm gonna get my timer ready to go.
Start that timer.
Yep.
This is the one. Okay, this is the one that's on it.
Okay, this is this the shortest Sigbovik presentation? 3, 2, 1, go.
I hope so.
6 minutes and 50 seconds for questions.
Alright, question.
How did you practice speed running this competition?
It's all tool assisted.
Ah.
That was fast, but can we go faster?
Probably not.
Is this the shortest question?
No.
Is this?
So far, yes.
This?
Huh?
No.
Huh?
Sure. Yes.
Get the shortest answer.
Was this the frame perfect speed run?
No. Not at all.
Does that run in big O of n or n squared?
It's O of -1.
Why did you use 3 whole words?
Future work.
But since the presentation and the questions occupy at the same time, don't they sort of count in the same?
Shut up.
Plagiarism from Frieder. Shut up.
All right. Thanks all.
5 minutes and 20 seconds to spare. Well done. So I'm going to tell a boring story while the next presenter sets up. It's actually kind of interesting, boring. No, it's not interesting. It's just boring. Let's not kid ourselves. So I don't know if any of you listen to The Doors. Listen to the track "The End." Like, if you listen to that track, it's got some bizarre lyrics in it. Like, particularly, you know, "Ride the snake to the lake, the ancient lake. The snake is long, 7 mile. Ride the snake, it's old, the skin is cold," etc. And I used to say that all the time because I think it's a funny thing to say, especially when you're looking at directions. It's an interesting reference, and you know, reference is the heart of humor. I believe, at least in the modern era, reference is the heart of humor. Hashtag references, and so I used to say this all the time. And then one day, it was the end of winter, so I was playing "Summer's Almost Gone," that album, and I went to the end. Maybe it's not even in that album, but the point is, I was playing the end, and my wife was listening to the music and said, "Oh, wait a second, these are lyrics." This weird thing you say all the time is lyrics. It's not just a thing you say all the time. And yeah, it is lyrics. And wait, you married me? How did that work out? Yeah, gosh, that's bizarre. How's the setup going?
Almost done. Yeah, good.
Is it at the end? Question.
Awesome. All right. Ready to go?
Yeah.
Okay, this paper is titled, or this presentation is titled RRR for UUU, Exact Analysis of PQ Systems with Perfect Urinal Etiquette. Or etiquette, if you want to pronounce that differently.
Thanks, Jim. This is joint work with Christy Gardner. So, I'm sure all the fellows know what I'm talking about when I show them this picture with my clicker that is not turned on. So, that's cool. So what we see here is a typical urinal arrangement in something like an airport bathroom, other high volume bathroom. This bathroom designer has made a classic, very common mistake, which is that they haven't put dividers between the urinals, and they've spaced the urinals rather close together. And this is actually, so if you zoom in on this picture on this sign, you see that it's actually not English, so you think, okay, this is just a problem for other people. But this actually happens right here in Pittsburgh, at local establishments such as Fuel and Funnel. And so what happens when urinals are close together without dividers is that people don't use adjacent urinals at the same time. So as queuing theorists, we want to know exactly how many urinals we need to put in a bathroom. And the problem is that traditional queuing theory assumes that all the servers in the queuing system can be in use at the same time, unlike in the men's bathroom situation, where adjacent servers cannot be used at the same time. So, in our paper, we propose a solution to this problem. We introduce the Context to Unease Processing Network, or CTUPN model, which formalizes the constraint that men's bathrooms have in practice, which is that adjacent urinals cannot be occupied at the same time. So these situations are legal configurations in a CTUPN, but this one isn't. So, in our work, what we've done is we've used advanced Markov chain solving techniques to exactly analyze the 3 urinal system, assuming exponential service times and the Poisson arrival rate. So this is the NM3 CTUPN in traditional Kendall queuing notation, or for short, just UUU. So we can draw the Markov chain for this system, assuming arrival rate lambda and service rate at each server mu. So the system kind of alternates between 2 configurations. If an edge urinal is taken, we're kind of in happy mode, because you can have 2 people using the urinal at the same time, and you get service rate 2 mu. That is, you have two urinals at work at the same time, whittling down your queue. So you're kind of doing work faster. You can also be in sad mode if someone makes the mistake of picking a center urinal, which restricts the service rate to just mu. So what our model does is we say that when people enter a server, they choose an available server at random. So once the middle person leaves, the next person will either choose an edge server or the central server. So this Markov chain has the property that it's a kind of one-dimensionally infinite chain, which is basically infinite Markov chains are bad news if you want to analyze them exactly. Remarkably, there's a technique that applies to exactly analyze this chain. The key is that the arrows between these layers only go up. So we can use a technique invented here at CMU called recursive renewal reward, or RRR, to get a simple closed form solution for specifically the Z transform of the number of people in the queue at any time. I guess this is a big expression, but this is actually sort of remarkable that this works at all. We also in our paper consider alternative urinal topologies more than just the traditional row. So we consider circular. actually, small note, this kind of picture appears to be a CUP, but topologically it's really just a row of urinals because there has to be a door somewhere. And I guess maybe people like enter fire station styles. So to really implement this in practice, you'd want a central column and urinals positioned around that column, which might cause other issues that we'll get to in a second. But so the neat thing about circular urinal positioning is that it actually makes the systems a lot easier to analyze. So if you have a row of 7 urinals, you have to analyze all sorts of things that can happen. When someone leaves the queue, if this guy leaves, the next person can take the same urinal or a different urinal. So you have this very complicated state transition diagram, which makes this hard to analyze, in fact, impossible with normal RLR. But when you have a CUP queue, everything is great. So, for future work, so it's well known that laboratories are actually multi-class queuing systems with class 1 and class 2 customers. Remarkably, that same laboratory at Fuel and Fuddle not only has no divider between the urinals, it also has no door on the stall. So considering unease in a multi-class queuing with multiple servers and multiple classes of customers is an unfortunately practical problem. We also have considered possible other generalizations of the model. For example, so the traditional urinal system you can think of as a path graph, where vertices have degree less than 2. You can imagine CNUPN systems that involve unease graphs of degree greater than 2. Finally, we can consider the continuous case. That's it. Questions? That's an excellent point. So one goal of our work is to basically make it possible for laboratory designers to analyze the cost trade-off between hiring someone to smash every second urinal and just putting up with the suboptimal performance. Great question. All right, well, thank you very much.
Properly that we seem to be down to our last, I guess, demonstration in this case. All right. So while they set up this, do you have a slides and a demonstration, or simply a demonstration?
Yeah, we have both. So first off, we're gonna need. Wait, Zach, did you want to say something? Okay, we're gonna need 8 volunteers from the audience. And don't worry, you will almost certainly survive.
Okay, so it's a non-deadly demonstration.
Yeah.
That's an expectation.
Okay, we didn't actually specify at the beginning that you shouldn't have a deadly demonstration, but I guess we sort of counted on common sense, which maybe we shouldn't have given what we see here today.
Okay, so we have one. Okay, cool. Come on down.
We're never actually called. Do I just like walk on stage?
Yeah, just walk down here.
Okay.
Okay.
Come over to where to me.
Looks like we have 3 volunteers, 4 volunteers.
Carlo, you don't have self-respect.
I'll just go.
Baby, but I figured you out, and you're thinking we'll be fine again, but not this time around.
Gender ratios.
Okay. So, does anyone know? Did that? Can you? I mean, So, today we'll be talking about games, and more specifically, games of the sort where you have to imbibe poisonous liquids. So as you can see, games are very popular, and they're one of the most fruitful areas of research in universities across the U.S. In Figure 1, you can see the highest paid salaries of public employees. And so obviously, games are a very fruitful and lucrative area of research, but what about games where you drink toxic liquids? These kinds of games have definitely not seen nearly as much academic research, and we would like to rectify that situation. So we propose design principles of drinking games. The first principle is that they should be easy to organize, and you should follow the ABCDEs for this. These games should be active, they should have heavy pace, and they should be brainless, and people might be clumsy in dancing, and there's a lot of entropy. Oh, exactly. Maybe like 12% up.
We're good.
These games should inherently be social, so we want to avoid people standing around aimlessly looking and not doing anything. In other words, non-compliant prairie dogs, NP. We should avoid players not playing, so P equals NP. And we should keep entering and exiting games. In other words, don't forget the can. These games should be of appropriate difficulty, so they shouldn't be completely not playable, or NP complete. And of course, the game should have low cost and high reward. So we have to calibrate the the primary investment energy gift, ping, against the principal outcome and principal output end game, pong. And finally, drinking is utterly integral to the game. So we need to have DUI. Thank you. So now we're going to begin a live demonstration.
So we thoroughly tested our theory, and so what we're going to be doing is a live audience demonstration. If it doesn't work, it's your guys' fault. So, the rules of the game are that one team composed of the batters here and the other team composed of the fielders are organized as so. The batters, they throw the ping pong balls in and try to shoot for these cups here. This is first, second, third, and in our minimal preparation, home. So, you guys can start.
Yeah, so you don't have to worry about the rules. You don't have to really worry about the rules, but like, batters can try to hit one of the base cups, and they should try to avoid the out cups. And they have 3 chances to hit one of the base cups. Work it out. And of course, when the batter hits one of these cups, say first base, they have to run to first base. Or second base, they have to run to second base, third, or home. So yeah, go ahead.
So strike one. Alright, so you got first, but you don't get to go.
That's a hit.
Just jet. So you're the fielder for first, so now you get to go shoot.
He does run to it.
Okay.
Right, first or like physically first base?
You're first base. So,
Wait, I do the thing now?
yeah, you try to shoot for that cup, and
So on the field, so after the batter hits, the fielder can try to hit the same cup, and if he hits it, the batter's still out. That's so much fun. Also, if the fielder hits one of the out cups, it's an error, and then that is the ball. And that's how the game keeps going. Alright, so the batters keep going. Make sure to run to the base, otherwise you'll ruin our sample.
you know,
You're right.
So that's an out.
You're right.
Perhaps
You can
take some
go again
questions
later.
from the audience to further complicate this demonstration.
Okay.
Main question. The question is, when do you drink?
You drink whenever the batter is home. Another team has to drink. Also, how much time do we have? Can this be the after party?
Wait, what happens?
Any further questions from the audience?
The first batter can go again.
Completely out.
But the batter can go again.
Okay. Very cool. Thank you.
All right, well, applause for the demonstration. And so concludes another Sigbovik is what I would be saying, except we have one more thing to do. And that thing is the final award, the Audience Choice Award, the People's Democratic Choice Award. This award is traditionally, exclusively, and always awarded based on the loudest applause. That applause can be directed to one of the talks. Now, traditionally, the MC is not capable of judging applause. Okay, that's not even true because Tom's good at it. Tom, can you judge applause?
Yeah.
Awesome.
Definitely.
Awesome. So.
I'll use the audio meter.
Good. Good, you're ready.
This is just the People's Choice Award. This isn't the Democratic People's Choice Award.
Oh, okay. I didn't actually look at the title on that award. That's on me, I suppose. All right. Just wait and see if it displays this. It doesn't really matter. So, what we're going to do is I'm going to point at these presentations, and if you like them, you should applaud. And if you like them more, you should applaud more. And if you like them less, you should applaud less. Are we still getting set up on that audio meter?
Ready.
He's ready. All right, I was almost going to bring out the joke book. I think there's a really good one right at the beginning. You know, I'm going to go because Tom's kind of, he's looking at the thing, he's thinking. Okay, I'm going to point. So now this is going to be done in a single blinded manner. So Tom isn't going to know what I'm pointing at, although I am pointing at them in numerical order. So maybe he does know. And I'm also going to announce the title of the talk as I go through.
I can't influence this, except by speaking.
Okay. So first there was me doing a ridiculous accent.
It's -3 decibels.
Okay. Should I write that down? I'm going to write that down. -3. Okay. Next was Michael Koblenz. What was the talk?
Zero color.
Posters. Zero color theorem.
I definitely touched 0 decibels.
Ooh, 0. Excellent. Next was Julian Whitman doing
Robot empathy.
Robot empathy.
I found out that 0 decibels is the max. But it touched it 5 times.
Okay, so 5x0. Awesome.
Okay, we sold them.
BlackBerry debugging was the next talk. Although I kind of like the quiz aspect of this, but okay, BlackBerry debugging.
1x 0 decibels.
1x0, a respectable score. Practical threading for vfunge.
That was 3x 0. You're all getting louder, or is the talk getting better?
Louder clearly is not the way to go. We want to make sure we just like are in sync.
You want distinct waves of loudness, which is hard to achieve.
Okay, PowerPoint Turing machine.
That was 10x 0 decibels. One of them was especially long, like the red light was just.
I'm going to underline the 10. Garbage collection with a call interruption was the next one.
-4 decibels.
Fake news logic. Fake news logic.
-1.5 decibels.
I didn't even know there were two significant figures here.
Well, yeah.
Okay. Syntax highlighting for programming as a Wizzy
That was 5x 0 decibels.
Okay. Yeah, it's like backwards hex. Which means that this only got 1. Tom's excellent text-only executable compiler. He's giving a thumbs down. Let's hear.
X 0 decibels.
I'm actually going to use your little smiley face here.
Yeah.
Okay, moving to the second half, we had Brandon's startup idea. Yeah, the dating, rigorous dating with peer review.
0 decibels, just once.
Okay.
You're going to have to vote for the cake.
Cake is not a paper.
Yeah, I've got to say, like, I thought it might be a little too real, but I guess it wasn't too real. It was just real enough. Okay. Who sorts the sorters?
3x 0 decibels.
Are you going to sort that one?
The big data visualization demo.
Also 3x 0.
What was that again?
3x 0 decibels.
3x 0. I'm wondering if my list is now out of sync with my other list, but
Those
whatever.
are out of order, but it doesn't matter.
Too bad.
Yeah, that's what I was gonna say.
Okay, they're the same. Okay, awesome. The shortest presentation.
2 times 0 decibels.
Not the shortest of
Yeah, you all clapped way too long. This is a joke.
Yeah, maybe we should try that again. Okay, let's do the applause, but do it all very much at the same time. I'll count you
Synchronize it,
down.
yeah.
Clap on 0. 3, 2, 1.
That was very stark on the.
That was the shortest applause. And I think that's a good thing. Finally, the urinal etiquette presentation.
About 4x 0 decibels.
And this incomprehensible baseball-based drinking in it was the last thing. So, yeah.
-1 decibels.
Okay, so selecting visually the highest number. I think it has to go to. I don't think we should sort these. It just seems cumbersome.
Quick select. Yes.
Yeah. PowerPoint. Yes. The PowerPoint Turing machine. Are you still in the building?
I'm here.
The people loved it. I have no idea where the awards thing is. I'm going to see if it's on the table over here. Or no, is it over with the preparation table because you were, is it under the cake? That would be troublesome. Oh, that's brilliant. Okay, as the is being filled out, are there any final comments or notes from the organizing committee?
Thanks, guys.
Yeah, thank you again, organizing committee. One final demographic note. Not going to have people raise their hands, but I look out in the audience and I see a lot of people who are members of groups that are underrepresented at Sigbovik. If you believe yourself to be a member of a group that is underrepresented at Sigbovik, invite other members of that group to Sigbovik next year. I don't think it would fix the situation since everyone could select themselves into a group of only themselves. But
Then you can't invite only yourself.
well, you could come back. But I think it would be interesting as an experiment to see if we can popularize Sigbovik still further and encourage even more great work of the caliber that we have seen here tonight. With that, thank you all. I hope you had a great Sigbovik 2K.